All right, so let's take a look at an inductive approach to determining the derivative of cosine. We looked at a very deductive approach to sine in the other video where we proved it without a shadow of a doubt. In this, we're going to look at it a little less formally, and we're going to kind of look at the graph, estimate slopes of tangent lines, plot some points, and see if we can find a curve that fits it. All right, so first thing we're going to do here is we'll start at 0 because it's a nice easy value. And at 0, it looks like the tangent line on this would be horizontal, all right, which means that its slope is 0. So I'm going to go ahead and plot that at 0, the slope of the tangent line is 0. All right, so that's our first black dot there. All right, then I'm going to go over to pi over 2, and I'm going to do the same thing. But at pi over 2, notice how it's coming down the page. Now, if you remember how we approached the squeeze theorem, showing sine x over x, we really narrowed in on this point right here, having a slope of positive 1 if it's going up. But this one's coming down, so we're at a negative 1. All right, so we'll go ahead and plot that. Then if we go to pi, all right, at pi it looks like we're back to a horizontal tangent line, so we've got 0. All right, so at 0 the slope is 0. At pi over 2 the slope is negative 1. At pi the slope is 0. So we'll go to 3 pi over 2. All right, and at 3 pi over 2, it looks like we're at a positive 1 slope. So we'll plot that, and then at 2 pi, it looks like we're back to a 0. So we're starting to see some of that oscillation that we typically encounter with sine, cosine. So let's go one in reverse just to see if we're seeing a similar pattern and there's no surprises. So we'll look at negative pi over 2. And at negative pi over 2, it looks like we're going up from left to right. So that's going to be positive. And we'd have a slope of 1. All right, so we see these points. Now, if you take a look at that for a few seconds here and try and figure out, what would fit that. Typically in class, I see a lot of people initially say sine. All right, so if we take a look at sine of x, all right, you're going to notice that we missed the points. All right, and this is because coming out of 0, 0, the graph would actually go up instead of down to that first red point we had there. So I'm going to go ahead and flip this over to negative sine x. And notice right there we run through all the points perfectly. All right, and that's kind of an informal argument for why the derivative of cosine is negative sine. All right, so the derivative of cosine is negative sine, and that kind of gives us an inductive / informal approach to demonstrate that this would be the case. All right, so I hope that helped and gave a little bit of basis for this. I really don't like using formulas without some level of basis, whether it's deductive or inductive. All right, thanks, bye.